When we think about the architects of artificial intelligence, we usually picture software executives like OpenAI's Sam Altman or the leadership at Google and Meta. But those companies do not control the intelligence they produce. They are completely dependent on a physical infrastructure built by a single hardware manufacturer. By the time the industry recognized this absolute reliance, the hardware foundation for the next decade of progress had already been set. In 1993, three engineers met at a San Jose diner with a specific goal: making video game graphics run faster. 4 years later, their company nearly collapsed. Desperate for a lifeline, they asked Sega for a $5 million contract cancellation fee just to avoid bankruptcy. Then, in 2006, they released CUDA. This software platform allowed their graphics chips to perform heavy, generalized math, an expensive pivot that Wall Street analysts initially viewed as a waste of profit margins. They were not executing a master plan, they were simply trying to survive, but in doing so, they constructed the exact mathematical foundation required for an AI future that did not yet exist. That future arrived in 2012, when a graduate student named Alex Krzyzewski began training a computer vision model called AlexNet. Instead of booking time on a traditional institutional supercomputer, he ran the model from his bedroom using 2 consumer-grade gaming graphics cards. After 6 days of processing, AlexNet crushed the world's most powerful machines in image recognition accuracy. Artificial intelligence had finally proven its viability. But because the breakthrough happened on gaming hardware, the future of the field became permanently tied to NVIDIA's specific architecture. 4 years later, in 2016, NVIDIA CEO Jensen Huang hand-delivered his company's first AI supercomputer to Elon Musk and a small nonprofit startup called OpenAI. At the time, almost no one else in the tech industry wanted to buy one. That indifference vanished with the public launch of ChatGPT. Almost overnight, tech companies began a frantic global scramble to secure NVIDIA's new H100 chip. The scale of this spending was massive. Meta alone committed roughly $9 billion to stockpile 350,000 of these processors. The power structure of Silicon Valley inverted. The leaders of the world's wealthiest software companies were now standing in line, begging a single man for their hardware allocations. The physical reality of the AI boom is that you cannot simply manufacture more H100 chips on demand. This silicon wafer is undergoing a microscopic packaging process known as CoWoS, which binds the processor to its memory. Currently, only TSMC in Taiwan has the capability to perform this at scale. As this map illustrates, the ultimate choke point is even narrower. The critical TRX50 substrate required for these chips is sourced almost entirely from a handful of factories in Japan and Taiwan. This absolute physical scarcity drove H100 rental prices up by 40% in a matter of months, forcing startups to burn through their venture funding just for temporary access to compute power. The shortage has grown so severe that sovereign nations are now deploying shell companies to bypass traditional procurement lines and hoard the chips for themselves. This supply chain control gives NVIDIA the power to decide which technological ambitions are realized and which are stalled at the factory door. This raw computing power is now undergoing a rapid physical compression, marked by the 2025 handoff of the DGX Spark. This device delivers an entire petaflop of supercomputing power, a capacity that used to require a massive server room, compressed into a 1.2 kilogram box that sits on a desk. This portability escalated the stakes. In May 2026, the U.S. Pentagon bypassed ethical holdouts and signed classified contracts with 8 major AI firms. NVIDIA's silicon is now being actively integrated into the military's Impact Level 6 and 7 classified networks. The United States military is actively transforming into an autonomous, AI-first fighting force, one that is completely reliant on this specific hardware pipeline. Historically, society's fear of artificial intelligence centered around rogue algorithms and autonomous software. But because we were so focused on the code, we failed to notice that the physical hardware had already won the war. We have transitioned into an era where high-level intelligence is a physical, mined resource, and the equipment required to extract it belongs to one company.